Okay, so let's first discuss how we can use LLM uh, for legal, like how uh, structured data and LLM can create magic for LLM. They can have a they create a great combination. Uh, okay, so let's first see like what LLM is. Okay, so LLM is you might have heard about transformers, right? So those are like transformers which were trained on very large data, okay, and they got a thinking capability of a human. They are trained on very large data, okay, and they are not just used for a same task. Uh, they can be used for various tasks. So let's first discuss what LLMs are. Okay. So LLM is a artificial intelligence that can generate human-like text, and they can perform various natural language tasks. Okay. So you can ask them questions. You can ask them to summarize some text. Okay. Then you can ask them to find insights in some of the text. Any task, whatever NLP task you can have, that can be done with the help of LLMs. Okay. Now let's just see LLM at a higher view, like what are the blocks in the LLM. I won't go in deep regarding this because let's cover the most important part first. Uh, the more details about LLMs, transformers, and everything you can find on net and various videos. Okay. So there is a decoder block. So what is the task of decoder block is it tries to understand what your text is. Now how it tries to understand, like in previous uh, architecture, what it used to do was take the first word, then with the help of the first word try to understand the meaning of the second word, then third word, fourth word, like that. But in encoder what they did was they passed all the text parallelly. So again, by using parallel approach, we can save time, and they introduce something known as attention. So what attention is, like whenever a human being reads a sentence, he focuses on some of the important words, right, to understand the text. So the same capability was introduced in the transformers. So they were good at understanding text as well as generating the text. Okay. So whatever you see in the decoder block to the right side, there is a multi-head attention block, right? So multiple attentions were proposed. Multiple attention blocks were added. So why multiple? Because the aim was that each block can understand differently, like which words are important for the current one. And the working of the multi-head is, if I go in mathematical terms, it is nothing but the weighted sum for a particular word. Okay. Now we can see like what is prompting in LLM. So prompting is the way with which we can interact with the LLM. Okay. The more accurately you prompt, that means the more accurately you try to explain the LLM, the better it will work. Okay. Maybe you can see a small example like how we can use prompting to get output from the LLM. So I have given a story to the LLM, as you can see. And what I have asked is read the story properly and identify the characters in the story. That means who are the characters. And also I have asked the LLM to respond the characters in JSON format. Okay. So let's see the output. So this is the characters in the story, that is Lily and Tom. So LLM is able to identify the characters as well as it is able to return in JSON format. Similarly, I can ask it to give in CSV format as well. It is just like human. So how accurately you give human a task, like how properly you define a task to the human, the more accurately it will work. Similarly, the LLM is doing. Okay. So this was about prompting. Most of you might be knowing this, but just to cover like completeness, I'm covering this. Now let's understand what is RAG. Before RAG, what I would like to say is LLMs store the information in the form of numbers. Okay, they don't have a database like where they can say, okay, I have stored this data, or when I have stored this data. So it is like a black box. No one is knowing like what internally it is working. Now what happens is, let's say I ask a question and he is not knowing the answer. As there is no defined database where it will be searching, it will try to assume the answer or it will try to guess the answer. But we won't be knowing that, yeah, the answer is right or wrong. So still it will give the answer. Uh, in like critical fields like medical or some critical tasks, giving wrong answers and a human working on that answer might create problems. So this is known as hallucination. So to avoid hallucination, what we do is we give some piece of information from where it can fetch the data. So let's say someone asks a question about define derivatives. So what I can give is like I can give the whole Wikipedia page of derivatives to it, and I will say, okay, give me the answer from this page only, and the whole page will be included in the prompt as prompt. Now with this we can mitigate the problem of hallucination, like it knows where to find the answer. And as it has a general knowledge capabilities, it can search the answer in the text, like the Wikipedia page which I have given. So the method which I defined is called as retrieval augmented approach. So here you can see there is a knowledge base. From the knowledge base, depending upon the query, I can retrieve important documents. Then I can give it to the LLM as well as my query. Now the LLM task is to answer the query by having the information. This is how the human works, right? Whenever someone asks you a question, if you don't know, you search on the Google and try to guess the answer, and then you will be having a response. So this is all about RAG and why RAG is required. Uh, just an illustration, like there will be large number of PDFs. I can chunk them and I can store in a vector database. To simplify it, you can assume a database where I can search, let's say, some word, and all the relevant documents will be retrieved. And how it is done is, it is done with vector simulatory search. So every document will be represented in some vector format, and my query will also be converted to a vector, and we try to find out like which documents are related to my query. And then those answers and question is fed to the document, and the LLM tries to respond. This diagram is clear, right? Anyone is having issue with this? Now let's identify what are the challenges with this approach. As documents may have repeated information and there is no structure in the document, right? So each document may have repeated information. So as the human gets confused, similarly the LLM can get confused. Okay. Then the as due to compute and input limitation to the LLM, let's say we chunk the document, like break the documents. Now breaking the documents, we might miss some of the information and it won't be able to link it back. Then another question is how much document should we search? Like as a human also let's say we are not sure about answer, then at some point we stop, right? Like, okay, now I'm not getting the answer, let's stop it now. Similarly, the question is for LLM, right? How much document should we pass? 100,000. There are n number of documents. Passing everything is not possible. So all those challenges comes when you try to pass documents to the LLM. Uh, that's why it is better to use a knowledge graph. Now, what is a knowledge graph? Knowledge graph is a structured representation of a document or any information where you have a node and there is a relationship between the node. Like the user participates in a competition or student studies this subject like this. Now here what happens, how much times your name will come, there will be only one node for it. There won't be multiple information. So we can make sure that it is unique and uh, also we can solve the reference problem like I can get all the related nodes to the my user and so I won't be missing any information. And as only node information is there and the properties, the data will be small. So you can pass a big, um, so you can pass a large number of nodes and relations to it. So that is the advantage of using knowledge graph over documents. Uh, we don't have to make much of the changes as there was a document base. There is now a knowledge graph. Users ask a question. Now you will the question the LLM can convert into a cipher query. Now what is a cipher query? Just like database has SQL, right, to fetch the information. Similarly, the cipher query is used to fetch the information in the knowledge graph, and all the relevant information can be retrieved. Now, question and relevant information will be given to the LLM, and you can generate answer. So similarly, yesterday, Modi sir covered, right? Why it was better to pass the subject relation object in the prior case retrieval. Like it was better than passing the whole paragraph. So similarly, here also you can get multiple advantages. Now this is about knowledge graph, but now knowledge graph, let's say, okay, we have information in the knowledge graph, but we want to segregate it or we have to give a unified name to it. So how can you use that? Okay, that means let's say my name is Dhananjay, we have Abhinav, and we enter the data. Now we all are students of IIT, right? So we are students. So it is just like you might have learned about object and class, right? In Java or anything. Like class defines some properties and object is the instantiation of that. Similarly, a knowledge graph is the instantiation of ontology. Ontology defines uh, the characteristics or like the you can just assume ontology is giving a unique name to a group of things with which it helps in searching, finding everything is done easy with it. Or you can say it is given a label to the data. So you can just ask, give me all the students, so Maya and Abhinav name will be retrieved. Otherwise, it will be difficult to identify like what is that, like it is easier teacher or student or what he is. So that's why ontology is important. Similarly, yesterday we seen some of the ontologies. So here is the example of one more ontology. Here you can see employee is related to employer. Then employer is a subclass of role in matter, whereas role in matter is a subclass of a actor slash player. So actors like player are all the actors who take part in a legal process. It can be a judge, anything. Now there are multiple subclasses of it. Now all the actors which take part in matter role, those are called as role in matter actors, and there the employer and employees comes. Again, you can see that employee is related to labor and employment law, where employment law is a subclass of area of law. So with this ontology, you can have a structure, right? So any questions regarding this? Yeah, these are all entities in the ontology. You can consider them as a classes. And we can have a instantiation like object for each of the class. Like let's say I'm an employee. So I will be tagged with the employee tag. My employer was MSCI. So MSCI will be a node in the knowledge graph, which will be linked to the employer. So now if I want to identify who is the employee of MSCI, I can see that MSCI is an employer and employer is connected to employer. So I can fetch all the employees who are connected to MSCI, with which I can identify, okay, the name is Dhananjay. Similarly, as covered yesterday, there is an ontology for legal part. It is just a flow representation of all the legal, like you can assume whatever legal classes are there, everything is present in this sample. Okay, so generally it is better to use this I mean ready-made ontology and try to achieve your solution. And again, it is an open source, so you don't have to pay anything to use the ontology. This is a sample part which yesterday sir, Joseph sir have also displayed that. As you can see, a shoplifting is a type of criminal law. I mean, it is tagged as a criminal law. So criminal law was a node in the ontology. And similarly, shoplifting can be a node in the knowledge graph. So criminal law is a class, shoplifting is the object of it. And various tags you can do. So this is the tagging, like identifying which of the class my word belongs to from the ontology. Any issue with this? Or As I shown, like they have a very superclass that is thing. Under that superclass, various subclasses are there. Actors like player, that who are the participants in the law, what are the areas of law, then currency, what documents are present in the law, everything. You can just explore these things. Let's say I search for judge. You can see judge is under actor slash player. Under that, it is in role in matter. Then who are all the decision makers for legal dispute. And these are all the decision maker in the legal disputes. Then there is a judge. Now again, judge can be of appellate court judge and trial court judge. Again, trial court judge can be of two types, three types: administrative law judge, justice of peace magistrate judge. So everything they have created, and not only the parent-child structure, but they also have the relationship between them. That means judge, you see over here, is the author of judicial opinion. Now, the judicial opinion is a subtype of trial court created documents. Law students might be knowing this better. Then it is related to the judgment as well. So all the relations they have created in this ontology. You can explore the tool. This tool is great, and there is various information for that. Again, you can see that node has the properties. It just don't have relations. So what are the properties? Now judge has a label like this is the IR attack. Now why IR attack they have used? Because there can be a same name for multiple things. So just to have a unique thing, they have created IR attack. Now they have added the definition of the judge, then all the relationship, work for court forum, ruled upon litigation document, everything is there. Now how can I use this? There is a search tool they have created like just to tag, let's say I type judge. I can get the IRR for this. Like what is the salary tag present for my particular word. And once I select it, I can just download it and see like what are all the suggestions it has made. So if you see, they have given me the IRR as well. They have given me the definition, all those things. Again, what I can do is I can add some section or let's say a date. First, they have given me various suggestions that way, whether it is a registration date, expiration date, or is it a event, is it a matter of opening, and I can select it and tag it. Now, how this is working is they are not just searching in the ontology. So the first thing what they do is first they search in the ontology for whether the given word is present in the definition or in the links or wherever it is given it or not. But there can be some words which are not given in the ontology. So for those words, they rely upon LLM. So they give a bunch of tags to the LLM and ask LLM to tag it and give what is the probability for it. So with this, so here you can see the source is LLM. That means this thing, the LLM has suggested that it can be a registration salary tag. Similarly, if I type here as advocate. Again, it is a source is LLM. But if I type a lawyer over here, source is label. That means it has searched in the ontology, it got the exact text and it gave, and the matching percentage is 100%. So this is the advantage of this tool that not only you can just tag all the things which are present in ontology, but there can be multiple names for the things which are present in ontology. So with the help of LLM, you can achieve this thing. So whole yeah.
We to decide what is the IRI for our tech.
Yeah. So we'll
It is
be
not in selling.
uh, I mean,
If it is not present in selling,
but there is another word for it, right? In the Sally or not? If another word is present in the Sally, the LLM will be able to identify it, right? That's what it is doing. Wherever the source you see as LLM, the word is not present exactly in the Sally. But as large language model has the capacity to understand the words, it can understand the word and just like RAG, retrieval augmented, you give some text, right, or source. Similarly, we will be giving the tags from the Sally. I will show you the prompt and the code as well. So from that, I will say these are the bunch of tags which are present in Sally, and I have this word. Now give me what are all the matching tags for it, like which are the most probability, which has the most which tags has the most probability for this word. So that way we can get the tag. And let's say if the tag is not at all present in the Sally, like not its relevant word as well, then you can just add it to the knowledge graph. Now let's go little bit into this API. So this tool at the backend uses this API. As you know, the Sally has a large number of tags. Just asking an LLM or a person directly, like giving him thousands or I think 50,000, 30 lakhs of some tags are there. Just giving all those tags and asking LLM will be a bad idea because a human will also get confused with this huge number of tags, right? So first, what we will be doing is first we will be identifying from these main categories where the word belongs. Okay, so for that we have a API to suggest concept. So concept is nothing but a top level subpart of the study type. So here if I type judge and if I execute, so it is saying that 90% chance is there that it is a actor slash player. That means the tag which you are searching will there is a probability of 90% that you will be finding that in the actor slash player. Now as I know it is an actor slash player, there is another API for to search in the actor slash player. Similarly for all those things we have like forums and venues, legal authorities, location. Let's say I type USA, it it should give me a location part. So it is saying that 90% it is a subcategory of location. Now I can just call to the location API. So here if you see, this is the location API. I can type here as USA. I think it has I can type. So as you can see, it has matched the exact Texas tag because Texas is a state in USA. So similarly, you can fine grain it like slowly because it is a very huge tree, right? So going level by level, you can get more accuracy. Now moving to the code for this, like how they are doing, maybe you can see what prompts they are giving to it. So this is the logged prompt from the code. So whenever we give some word and ask what is the concept for that word, this is the prompt which is given to the LLM. That these are all the concept types. So this is nothing but an example of retrieval augmented generation, where you give some reference to the LLM so that it can predict it. So you can see all the concept types are present over here. And then I'm prompting the LLM that you are an experienced legal working in a back office. Then these are all the tasks which I asked it to perform. Review the list of top level concepts, then review the user input, select zero or more concepts from the list, rank the selected concepts in order and return the order labels as JSON array. So this is nothing but prompting and augmented generation where you can achieve a great like proper answers from the LLM. Just asking the LLM, it might hallucinate because it has not stored any information. Similarly, a human might lie, right? If he does not know the answer. Any issues with this? So that is how you can use an ontology with the LLM to for various tasks. Like tag it, then once you have tagged it, yesterday as discussed, you can search it, you can group it, then let's say prior case retrieval, we can also increase the accuracy for it with this. Like we can have tags to the cases for what all areas of laws are present, criminal, everything. So I can just say, okay, give me the criminal cases. So the searching and everything will be very easy. So that is why uh, everyone is going towards ontology and LLM. Okay, we have a small demo for this. Whoever wants to try it, like you can just write. So there is a notebook for this. Uh, just type this on Google and you can have that notebook. Hmm.
We copy it in our textbooks, in a message.
No. What a knowledge graph is, what is ontology, how to create knowledge graph and ontologies. So there are various, as I described, you can, the easiest thing might be to visualize it as a, let me share the link. As I said, knowledge graph is an object and ontology is a class. If you understand object-oriented programming. I hope everyone has copied the URL. You might be able to see a notebook. Now, before that, as we'll be using ChatGPT, we need to create an API key for it. Okay. So you guys can just copy this URL as well. It will just ask a Google login. You can use that. And in the left sidebar, you will be seeing API keys, and there you can create a new secret key. Everyone is able to do. Were you able to see the origin, the first thing? नहीं यहाँ से कॉपी कर टाइप को करना अच्छा वो दिख नहीं रहा है थोड़ा बड़ा कर दो गो टू द ओरिजिनल लिंक एंड मेक इट बिगर हाँ मे बी पुट ऑन योर स्लाइड एंड मेक इट फॉन्ट साइज इंक्रीज इन दोनों का फॉन्ट साइज मेक इट 24 और 3 मे बी 13 हाँ दैट्स गुड वो फर्स्ट वाले का भी यूआरएल टाइमिंग है yeah so just copy these links everyone copy have we go to the error loading error Dhananjay okay you log into your Google account so he is able to open refresh and log in Google so इसको परमिशन दिए थे ना हाँ oh yeah, I'm able to open in incognito mode as well. Huh? You need to sign in. I think they are connected to post right election. Mobile apps. They may issue, right? Sign in to you was the error loading. even with the link.
No, this is not opening. It's किसी का भी नहीं खोल रहा है. No one is able to open. No one is able to open. Now it's open. Please refresh. They are able to open. Will be able. They are able to. Sign in only. You are able to open it.
Yeah, there is a Wi-Fi issue.
Some people are. So maybe, I mean, you. Whoever is connected to Wi-Fi. You are connected to Wi-Fi. Wi-Fi से we connected. You are connected to Wi-Fi.
Wi-Fi is not working properly.
मेरा भी इसलिए data.
Mhm.
खुल रहा है नहीं? Okay, maybe I will copy the link. Then you can type later. So he'll tell it. But those who have been able to open, you can type. Or maybe those who have been able to open, you can just check the there and see. How I've been able to open, so you can hear the system. Incognito mode में खुल रहा है, so एक बार खोल.
Okay, should we start? So you can create a new secret key so that you can access the PPT. Okay. Once you have created the key, just copy the key.
Everybody is able to get those who have access.
Huh? So open this platform.openapi.com/API keys. Now in the left sidebar, you will be having API keys. Then you can create a new secret key. And make sure you are logged into Google and with Google account or anything. Yeah, I hope everyone may be having the key, now just go to the notebook. You can run the first step. This is installing the dependencies. So what Dhananjay is, I remember we were prompting it, right? To give me the output in CSV, give me the output in JSON, everything, right? So a LangChain library has created the prompts for you. You don't have to write the prompts. You just have to use those prompts. There is a function for each of the prompt, and it will be kind of helping you to write the accurate prompt. Internally, all this code will be converted to a prompt whenever you deploy it. But it has given a structured function calls to it, like give me the output in JSON. So internally it will write a JSON. We will check the prompt, like what output we get. You are able to run this first step. Now this is a sample judgment. It is a very basic judgment.
Yes.
You can just and this is stored in the judgment object. Okay, so you can run that as well.
So if anyone faces from please
Just raise.
keep running. किसी को कोई प्रॉब्लम आनी तो पूछ लो.
Now as LLM will respond in the string, right? Handling it is quite difficult, passing and everything. So what we can do is we can create a response structure for it. So what I want is a response to be a list of entities. Now, what is entity will be? Entity will be having a name and value. So like that, we can create structures for it, for the response. So just run it. Now, this is the part where we'll be using the LangChain to prompt it. Now, what I am saying is you are a legal professional working in a back office of a law firm or corporate legal document and follow these instructions. Now, what are the instructions that from the given judgment summary, extract judge name, respondent, date of judgment, IP section, etc. So, what are legal things it can extract? Again, like you can try with various prompts, you can get various accurate answers. And then I'm just saying that parser.get format instruction. Now, parser I have used output parser, which takes a Python object. That means my response will be generated in the form of this object. That is, it will be having a response to the object where entities will be a list of entities. And so this will be a legal entity and this will be the value present. Let's say it can be judge and the name of the judge, the respondent, name of the respondent, section, ABC section. Now this will be the names which will be given by LLM, right? So it won't be common across everyone. That's why we'll be using the Sally tagging for it. Okay, so let's first get output from the LLM. So we'll just run that same. So if you see in out, it is getting the response from the chat GPT. Once you get a tick over here, you can parse the response. That means the string will be passed into the object where we want it. And when you print the response, you can see that it has extracted that it is a list of entities. And in that, there are multiple entities. So this is the first entity it has identified. That is the judge name, and the judge name is this. Then this is the respondent. This is the date of judgment. Then this is the IPC section used. So all these things are extracted from the given judgment. I hope everyone. Like you can try various things with this later whenever you can play with this. You can try with bigger judgments, different prompts. It might give different. You have to little it and try and look for a perfect prompt which will work for you. Now this is the API we use, right? This one. Like first what we did was we give a text. We identify like what is the main subclass for it, like whether it is an actor set pair, whether it is a date, or whether it is a document. Similarly, we have a code for it, which is get concept URL. So it just takes text and responds you the URL of the concept which we are going to fire. Let's say if I pass it and it is saying that it is an actor, I will get a URL of the actor. Now from that, I will just pass that text, same text and URL, and I can get the exact tag from the actor slash player. So whatever we were doing previously, right? First calling the concept, then depending upon the suggestions from the concept, going to the particular API where we can get a salary tag. And just I have created one function which is calling those two functions. First get the URL, then from that URL get the salary tag. Now what we'll be doing is we'll be passing all the extracted entities and identifying the salary tag for it. For that you can just run these two cells. And then when you see that it has started, that Mr. James Anderson is a dependent. Similarly like this, so this dependent is the Sally tag in the Sally. Okay, you can get the IRA as well. Like if you want some complicated workflow like store it in a database or anything, then it has identified that this date is the entry of judgment. There is this is also a tag in the Sally. So if you want to get more details about this tag, you can just go to that LLMs tool, search the particular tag, and you can get it. Like the parents are litigation events. This is the IRI, this is the label for it. I have just printed the label for it. Then this is the section, this is the section. So this is also a salary tag. Magistrate judge, this is also a salary tag. So all those subscript bold letters you are seeing, those are salary tags. Is this API access fee I'm getting? Yeah, so the error which you are getting is because of the rate limit. As we are using the free API, right, for from LLM, that's why you are getting that error. So if there is a limit that in 1 second you can only call some limited APIs. So that is given by OpenAI. You can just add a delay in it if you want to call multiple APIs. So yeah, this way you can achieve various things like ask GPT to extract entities, then tag it. Then these tags you can search it, like you can create a downstream tag for it. I hope everyone is clear about this. Any doubts regarding this?
Every time, if we have a bunch of paragraph, then we every time we have to pass each paragraph to ChatGPT.
You can pass. So there is a limit of 4,000 tokens. So if the paragraph is sitting in that, then you can just pass it in one go. So there are various approaches to solve this issue. So what they do is, let's say you have 100 paragraphs. So you will first summarize each paragraph with the help of element. Then you will combine those summaries and again you will ask to summarize it. So you will go up to the top of the tree and it will be kind of a comparison of your paragraph and that you can pass to the LLM. So there are various papers for this. Recently Google has published a paper. You can try that. At least not with code, but you can try with this prompting. Try to summarize each paragraph, store in a notepad, then give all those summaries and ask to summarize it. Then see what you can get. And Once you have a hands-on on this, you can try the LangChain API. It's quite good. All kinds of prompts are present. Retry prompt is also there. Let's say your JSON is incomplete, or let's say the API generated some wrong JSON. You can just ask GPT that this is the JSON generated and it is a wrong one. Just correct it for it will give you the corrected JSON. So all those kinds of functions they have already created in LangChain. You can explore that as well. And another question from that, can I use it only for ChatGPT? No. If you have if you have your LLM, you can integrate that in Sally API as well and in LangChain API as well. So Sally has released its code over here, that means the 273 ventures. So this was the API code which we are calling. Get concepts, from the concepts, get the let's actor slash player, then from the actor slash player identify the exact Sally get for it. You can go through the code, modify it however you want. If no more questions, we can stop. Thank you.